Okay, here we go. Now the classwork for 11.2, chords and arcs. This is going to be page 760, 1 through 17, 31 through 35 odd. And so let's go ahead and apply some of what we just learned to some of these problems. I've picked out 4 problems that I think are representative to review with you. Let's start with number 7. So number 7 is a really typical problem where I didn't draw the whole thing, but they give you a chart broken up. It's a pie chart broken up into percentages of home energy use. Again, thrilling. But the key is how to take a pie chart where you know the percentages and calculate the angles that are produced. Because that's what number 7 is asking. We're supposed to find the angle measurement, the measurement of angle for, I'm going to do number 7, SAQ. And that's because I thought this was a little trickier than number 5 and number 9. So let's see. Number 7, SAQ. There we go. I left my A off, so I couldn't find it. This is A. SAQ. So I'm trying to find this angle. Okay? And so the key, the standard procedure for solving a problem like this is that once you know the percentages, that is the percent of a whole. So in other words, I can see here that SAQ combines 6% and 11% of the energy use. So that means SAQ is 17% of the entire circle. Well, it's pretty easy to find a percentage amount of a whole because we can simply change this into its decimal form, 0.17. Okay? And then if we multiply a decimal times the total, that gives us that percentage. So in other words, 0.17 times the total degrees will tell me how many degrees this is. It'll give me that percentage. So if I know the total number of degrees, I can multiply that by 0.17 and I'll have this angle measurement right here. So do I know the total number of degrees in a circle? Yes, absolutely. The whole thing would be 360 degrees. So 100% or 1 would show I have 360. But in this case, 0.17 times 360, and I'll find out what 17% of 360 is. So we just put that in our calculator. There she is. 0.17 times 360, we get 61.2. So that is correct. So this angle measurement, SAQ, is 61.2 degrees. That simple. The other ones where they give you, if I just wanted this, RAQ, it would just be 0.11 times 360. Or if I just wanted SAR, it would be 0.06 times 360. SAQ required me to add up 2 of them, and so I just simply did that, and that's how we get our 61.2 degrees. So pretty easy type of problem once you understand what you're doing. Okay, number 11, we need to find the measure of an angle. In this case, we need to find of an arc. And so we have arc D. Let's make sure I get this right. We need to find the measure of DF. DF. So from here, is that correct? That's all we have to do? Sorry, double checking. Thought it was a little trickier than that, but no, it's just, I looked at the wrong problem. So so DF. Okay, so this is even easier than we thought. So DF, with these problems, you're always going to be doing some sort of combination of the angles, and knowing that they all add up to 360 or something, you'll be able to find the particular one they're looking for. So if I look at DF, I can see that the first thing I would notice, well, I know this is 90, and I know this is 51, but let's see. DF is simply this entire semicircle minus the 51 degrees. So in other words, CF is 180. I know that's a diameter, goes through the middle, it's a straight line. So this is 180, and so what I'm looking for is just that 180 minus the 51. So this is as simple as that is, 180 minus 51. And so DF, the measurement of actually it's arc, DF equals 129 degrees. Okay, so that was even easier than I thought. They can make these harder, but like I was thinking, and it's not even that much harder, but say you only wanted FE. Like say you just wanted this little piece here. Well, then I would know I have the whole semicircle is 180. I would subtract the 51. I could subtract DE because I know DE is 90, and that would leave me with FE. One thing to point out when you're doing this problem, notice I have another diameter here that I could use if I needed to, depending on what they asked me for. Also, when you have this here, these are vertical angles, CF to EB. So I know that these two guys are congruent. So that's important to keep in mind when solving these types of problems as well. There's all sorts of information within the circle to help you kind of add or subtract your way to the particular one they're looking for. Yeah, and this one was pretty straightforward. It was just a semicircle minus the CD portion, and that left me with DF. 129. Okay, number 17. So here we're going to be applying the fact that, look what we have. We have a diameter, and we have a secant line. And what we learned on the homework is when they are perpendicular to each other, I know, the important piece of information here is I know that this is congruent to this. And we are supposed to find RS. So yeah, so I need to find RS. So the trick here is, because we know perpendicular line, we're going to be able to create right triangles. And so if I can use right triangles, then I have my old friend Pythagoras to use. So the question is, I know that this distance is 5. I know that this distance, if I could find it, would be half of RS. So if I can find, there's no letter there, but if I can find this distance here to S, then I can double it, and I will have, RS. So can I create a right triangle using these two legs? Yes, I can. I can simply do that. And so I know that the PS squared equals these two legs added together because of Pythagorean theorem, where I have a squared plus b squared equals c squared. In this case, one leg is 5. I don't know this leg, and then here's PS. Now you might think, well, I don't know two of those. I know the 5, but I don't know this. Here's the simple trick to these problems. PS is a radius. Notice it's from the center of the circle to the edge. Well, I actually do know the radius of this circle because PQ is also a radius. And so I know what the radius is. The radius is 5 plus 8, 13. So that means any line I drew from the center out would be 13 in length, including PS. So I do know my hypotenuse. I know that that is 13. So that is always what you're going to be able to apply typically. If you can draw a radius, you know what that is if they've given you it in another place. So I can say a squared is 5 squared plus, I do not know, b squared. B squared is this piece right here. And then c is always your hypotenuse, and I know that my hypotenuse is 13. Okay, so I can now go 25 plus b squared equals 169. Subtract the 25. We'll go always really slow. No problem with you getting ahead of me. So b squared equals 144. Oh, they're so nice to us. 144. So I can simply square root both sides. It's a nice easy square root. Square root of 144 is 12. B equals 12. So that means this distance here to here is 12. Now obviously don't pick that on your quiz's answer. Don't stop there. They're going to try to trick you. That is half of, because I know these are perpendicular and this is a diameter, I know that that's half of the total. So RS is not 12, RS is 24. And that is our final answer, 24.0. Okay, so on problems like this, you're going to be using the Pythagorean theorem, and they'll always give you enough information to know two of the sides so that you can find the missing third side. In this case, remember that if you see one radius, you can draw and know that radius in any other location. All right, and finally, number 33. Just thought it'd be good detail to point out. It's not a hard problem. These are true or false. And this is that a central angle of a minor arc is acute. So this is just an important differentiation to note. A minor arc has to be less than 180 degrees. So this right here would be a minor arc. It's less than the diameter. It's less than halfway. Now it says that is an acute angle. Notice the difference in definitions. A minor arc has to be less than 180. But an acute angle, oops, can't write. Acute angle has to be less than what? 90 degrees. So in other words, this arc is less than 180, but I purposely gave an example of one that's more than 90. You know, 90 degrees would be somewhere around there. Actually, more like this. So a minor arc can be more than 90 degrees, and so number 33 is false. So remember the difference between minor arc and acute angle. Acute angles stop at 90. Minor arcs they're minor. They're less than something, but they're less than 180. And so you can have a minor arc that is acute, and that could be something smaller like this. But you can also have a minor arc like the first one I drew that is definitely not acute. It would be obtuse. So you can have both obtuse and acute angles that are still minor arcs. Okay, I know answered all the questions you could possibly have in your entire life, so go on and onward to victory, and let me know if you need any help.